today I am going to explain you an electromagnetic spectrum. Earlier in previous chapter we have seen about the phenomena of dispersion, which was the experiment done by Newton. What was dispersion? Dispersion is the phenomena of splitting of white light into its constituent colors by the prism. Means when the light passes through a prism, then a band of 7 colors is seen on the screen. So this band of 7 colors is known as visible spectrum. Why we are calling it as visible spectrum? Since we can see these colors on the screen by our naked eye. Okay. Thus, these bands of 7 colors is said to be spectrum or visible spectrum. But later by some experiment it has been observed that the sunlight is not limited to this type of spectrum. Means not limited to the spectrum in between violet and red colors, but it is having beyond the limit of red and beyond the limit of violet. Let us see how many different wavelengths beyond these limits are present in an electromagnetic spectrum. So, here I am showing you in angstrom and in nanometer. In both of the cases I would like to show you here 0.1 angstrom or 0.01 nanometer. Okay, here we are showing wavelength in increasing, wavelength in increasing order. Okay, wavelength in increasing order. So 0.1 angstrom. So the wavelength less than 0.1 angstrom is said to be gamma ray. Gamma ray. Okay, gamma ray. And till 100 angstrom, till 100 angstrom, it is X-ray. X-ray or 10 nanometer, or 10 nanometer, and here till 4000 angstrom or 400 nanometer. Okay, 2, here it is UV, ultraviolet rays. Okay. Now till 8000 angstrom or 800 nanometer, it is visible. Here it is visible spectrum. Okay, visible spectrum, that is big Q. Big Q. See, red is having more wavelength and violet is the minimum wavelength of visible spectrum. Okay, so 4000 to 8000. Here it is till 10 to the power 7 is of the order of 10 power 7 angstrom, or here order of 10 power 6 nanometer. Okay, so it is infrared. Infrared, IR. In short we write it as IR, infrared spectrum. Okay, and from 10 power 7 to 10 power 11 angstrom, 10 power 7 to 10 power 11 angstrom, it is microwave, and beyond 10 power 11 angstrom it is radio wave. Okay, it is 10 power 10 nanometer. Alright. In this way, it is obvious that the spectrum having wavelength or the waves less than 0.1 angstrom or 0.01 nanometer is said to be gamma ray. Okay, and the spectrum having the wavelength in between 0.1 to 100 angstrom or in nanometer it is 0.01 nanometer to 10 nanometer is said to be X-ray, and the spectrum having the wave of wavelength in the range between 100 angstrom to 4000 angstrom or 10 nanometer to 400 nanometer is said to be ultraviolet rays. And similarly, visible spectrum, as you know, a very thin range, okay, that is from 4000 to 8000 angstrom. It means from 400 nanometer to 800 nanometer is said to be visible spectrum, right? And here infrared, so 8000 angstrom to the order of 10 power 7 angstrom infrared, and between the range of 10 power 7 angstrom to 10 power 11 angstrom it is microwave, and beyond the 10 power 11 angstrom it is radio waves. Okay, so we have arranged an electromagnetic spectrum in their increasing order of wavelength. Okay, here it is quite clear that here we have taken the increasing order of their wavelength, while in upside I have written their frequencies. Okay, their frequencies, and the frequencies, as you know, the relation I would like to show in a corner. Okay, just see here in up corner. Since you know that V is equal to F lambda, here V is the velocity, or you can call it as C. If a light ray is traveling in a vacuum or in an air, then C is equal to F lambda. It means F is the frequency of the light and lambda is the wavelength. Okay, so this frequency F is equal to C by lambda. Okay, so if lambda will change its frequency, what means C is a constant value. C is a constant value. So what will happen? If C is constant, by using this relation for different lambda we can calculate their frequencies. So we have calculated these frequencies, that for this wavelength 10 power 11 angstrom light have the frequency 10 to 10 power 7 hertz. These frequencies are in hertz, and here this microwave have the range from here to here. This frequency you have to learn these all frequencies range. Okay, now just see from here one more thing. C is a constant value. It means the speed with which light travels through in air. Okay, it is a constant value. One more thing you need to take care: when a light enters into a medium and it disperses, means its speed may change. Okay, so if this speed will change, wavelength will change. Here the point you should note down that frequency will never change. Frequency is the source dependent. Okay, means if source will change, source of light or source of sound, whatever, if the source of light or source of sound will change, then only the frequency of the wave will change. Otherwise, if velocity will change, lambda will change, means their wavelength will change. Frequency will remain unchanged. Alright.